how do you refine gold? How do you get gold? This is a very important topic because we do have refiners, and traditionally till now gold is being refined by chemical process, which do have its own limitations. I'm not saying it's a process which can't give the best gold, but definitely it requires a lot of expertise. What I'll dwell with is, as I go along, I will highlight what is the process of refining which is followed by the refiners. In short, what we see is the effect of both chemical and electrolytic refining, and where one refiner should head to as they go along. And because this is very beneficial, because what we did at our factory is we did a small experiment where we found you can get much better gold by chemical refining, but you need expertise, and you can get the best gold by electrolytic refining, which is a proper process which may not require that much technical expertise. And what will happen when you get a gold which is free of impurities? You get better product in jewelry, you get less rejections, and that is what ultimately all the refiners should aim to give it to the jewelers. So let me start explaining what happens when the doré comes into the refinery. Most of the gold, I would say, is initially refined by doré received by a refiner, which is then followed by, also we do get a lot of recycling scrap, and that all scrap which is there is treated by chemical refining or electrolytic refining, and whatever doré is coming, again the same, both the processes are followed. Whatever gold we import from outside as bullion, they are all electrolytic refined, so in the first go you will get good jewelry, but subsequently there might be rejections as we go along. So when you get a doré, any refiner should first do a visual inspection, should have a radioactive check, because all this doré comes through a mines. So it is very important to have a radioactive check, and because if it is a radioactive gold, then that lot has to be quarantined, and subsequent authorities will have to take care of that. Visual checks gives a very good idea as to what kind of gold it is. If it is having a greenish tinge on, then you might say that it might have lead oxide. If it has reddish tinge, you might say it has high copper and you have to treat it in a different way. If it is having a grayish tinge, there might be iron, and then iron has to be removed by melting. And you also need to also do a magnetic check, because that will give you, if there is iron or nickel or cobalt, what process you need to adopt as you go along. So what happens in the first stage? The first stage of refining is melting of the gold. Once you melt the gold, then what you are doing is you are removing most of the impurities. Most of the impurities is either lead, bismuth, selenium, tellurium, arsenic, cadmium, which is all getting evaporated out as volatile elements. But still there will be some elements like copper, nickel, zinc will be left, which will increase in their concentration, but what we have to do is how you have to remove them as you go along, whether by chemical process or by electrolytic process. So before I go into details of chemical or electrolytic process, what I would like to highlight is what are the various refinery techniques which has been prevalent from years, in centuries. First, it was cupellation technique, where you had used lead to refine gold. Then came is the Miller process, where you were using chlorine gas, which was removing the silver as slag and what was left as gold. Later on came is inquartation, which is used still very much, where you are dissolving the silver out in nitric acid, and finally you are purifying gold. And to get and all this above first three process was giving gold which is up to 99% purity or even less. What we want or what we sell is either 999 gold or 995 gold, which you can get it by chemical process or by electrolytic process. So this is a simple demonstration of what is electrolytic refining and chemical refining. आप लोग सबको पता होगा. Electrolytic refining में you dissolve the gold, make an electrolyte, Whatever is the impure gold, you make it as anodes, you put it in the electrolytic cell, and as the current is passed, gold ions are getting dissolved into the electrolyte, which is a gold chloride solution, and from there, gold gets deposited onto the cathode as pure gold. And this gold is 49 purity gold, free of impurities. Whatever is the consumed, the anode gets consumed, and what you see below is the consumed anode is then recycled. In case of chemical refining, what happens? Again, the same gold, you dissolve it in aqua regia and then you precipitate using sodium metabisulfite. Once you do this precipitation, that is the skill which is very important, because gold you have dissolved. Now you need to see how you can avoid impurities also getting precipitated. And that is what we have seen at MMTC PAMP. We did a small experiment which I'll show you. What happens, and this is very crucial, what happens and what impurities get left behind in gold, which is detrimental to the consumer per se at the later date. After we have finished the gold refining, you get the decanted solution, which you then treat it, you pass it, because that solution may also have gold. So this, I'm just explaining the process or the trend which is going on currently. You pass it through filters, you pass it through ion exchange to collect all the gold. They may also have platinum, palladium, and then finally you neutralize the solution and then it goes to your effluent treatment plant for final disposal. So here I've just shown a comparison between electrolytic refining and chemical refining. Definitely electrolytic refining can be done in a large scale, while chemical refining, normally people do it in a small scale, and if you want to do in large scale, you need really large reactors to dissolve the gold. What electrolytic refining can give us is 4.9 plus gold, while chemical refining can give 4.9, but it's slightly difficult, and you need to stop the process at least 10 to 15% before, and that much gold will be residued in order to get better gold. The impurities are within the limits, while in chemical refining, as I'll show you, the impurities थोड़ी ज़्यादा चली जाती हैं. Cost, definitely cost in electrolytic refining, because it's a electrical process. तो उसमें the electricity cost is higher, though chemical cost is much lower, which I'll show you. While in case of chemical refining, electricity cost कम है, लेकिन आपका chemical cost बहुत ज़्यादा हो जाती है, और उसको treat करना is again a costly operation. Inventory, definitely in electrolytic refining आपकी inventory ज़्यादा रहेगी, chemical में उतनी कम रहेगी, and that's the reason why a lot of people want to go by chemical refining, but end of the day the trend is to go for electrolytic refining. Effluent generation ज़्यादा रहेगा chemical refining में, that's why you need to treat it, and as we go along with government very clear on pollution, sustainability norms, it's better to use a process which is less detrimental. And then overall the jewelry which is produced is much better by a gold which is coming from electrolytic refined gold rather than a chemical refined gold. These are few of the numbers, मैं ज़्यादा नहीं बताऊंगा, but ये है कि जैसे गोल्ड इन्वेंट्री कितनी लगती है. इलेक्ट्रोलाइटिक रिफाइनिंग में आपको 600 kg गोल्ड चाहिए होगा अगर 200 kg पर डे प्रोड्यूस करना है. वेल केमिकल रिफाइनिंग में आपको 200 kg ही गोल्ड आप एक दिन में प्रोड्यूस कर सकते हो. केमिकल दोनों में इनिशियली डिज़ोल्व करने में सेम लगेंगे, लेकिन ऑलमोस्ट डबल द केमिकल. आपको अगर 200 kg करना है इलेक्ट्रोलाइटिक रिफाइनिंग में, आपको 400 लीटर केमिकल्स यूज़ होंगे, वाइल एंड केमिकल रिफाइनिंग आपको 900 लीटर होगा. 900 लीटर का मतलब है आपको कितना ज़्यादा एक्स्ट्रा कॉस्ट, एक्स्ट्रा आई वुड से उसका एफ्लुएंट ट्रीटमेंट, वो सारी चीज़ें इन्वॉल्व हैं. एंड दिस इज़ द मोस्ट क्रूशियल पार्ट, एंड because of this chemical refining you will have to control the reaction to avoid impurities coming into it. Equipment is fine, manpower is not nominal, effluent generated is much higher, it is almost 4 to 5 times higher in case of chemical refining. Power cost is definitely, as I had indicated, is lesser in electrolytic refining. What does it do? Both of this generates NOx and SOx, and in order for that you will have to treat them. So you treat using scrubbers, and definitely in case of chemical you need to have extra scrubbers to avoid gases going out into the atmosphere. Then you have liquid effluents which you have to treat, and then you have the solid waste which has to be treated. Now here is the crucial part which I am coming to, where I have explained to you what happens in electrolytic refining and chemical refining. But what is the result? What are we giving it to the consumer? So what we did, we analyzed the gold. I would say MMTC PAMP gold we are refining by 100% electrolytic refining. Has impurities which are, you get 49 gold, you have silver and copper in ppm level. Even copper is less than 20 ppm. That's the limit which we maintain. But what you have seen, we also checked the gold which we got as recycled gold from the market, from various refiners, refined by chemical process. And we could find there is impurities like arsenic, there's impurities like iron, lead, manganese, and even tin. Tin was in a high quantity. So all these impurities will always have some sort of a detrimental effect when you manufacture your jewelry in the later process. So this is a periodic table. Everybody, most of them who are in the technical side will know it. You have the base metals, which is the iron, cobalt, nickel, copper, zinc, which is coming along with the gold. You have PGM, iridium, ruthenium, osmium, palladium, platinum, and you have all these deleterious elements which are your tin, lead, bismuth, antimony, and all those things which we will have to remove. And if these elements remain in your gold, what effect they have? Silver is okay, palladium is okay, aluminum will give brittleness, arsenic, tin will also give a bit of brittleness, but they may not manifest because they just evaporate. Copper is definitely there. It may have an effect on the color. Iron definitely will give you brittleness. Lead will is not allowed, but if it is there, it will result into cracking. Manganese again will result into corrosion and stress corrosion, which is there. If I talk of silicon, it will definitely, we do add silicon to have a deoxidizing property, but as it goes higher, then it will result into cracking. Tin, definitely it will give brittleness to the finished product, and tellurium and zinc also on the similar lines which is there. So we need to avoid all this, and this can be very well avoided when you do it by electrolytic refining. And these are some of the pictures which we demonstrated. Gold which is chemically used with chemical refined, you get oxidation, you get, and then you will have to clean it by sulfuric acid and all. We have even tried pink gold, and we saw a difference between a gold which is having impurities, which is turning black, while the one without impurities is giving us a good finish. And most important is the bullion bars. If you really want to go high into production, best process is electrolytic refining, and then you use the automatic furnace, continuous cast furnace. And in that, if you have a gold which is having less impurities, all those slag layers will not be there. As we talk about the trends, there is a new trend which is slowly coming up. It's a costly machine. It is acidless separation. What it does is, it evaporates, if you put a gold, it evaporates all the silver, all the impurities, and what is left is just gold and copper, and that you can take it through your normal process and refine it. So it's a very clean process. It is not requiring any of your chemicals. It doesn't require any of the treatment of fumes, treatment of waste, and overall the loss will be much, much lesser. So this will slowly become a thing of the future. Maybe 5 years, 10 years, 15 years down the line, people will start working on this or using this machine. And we did get testimony from people. We checked with a lot of jewelers what do they do. A lot of people are saying when they get a chemical refined gold, they do their second refining to avoid impurities and then process it. So I would thank my team who compiled this presentation. Thank you.